In this video, we're going to be evaluating an exponential function with base e that models a real-world situation. Okay, and we need a reminder that the initial amount is at the start time, which means t equals 0. When you're asked to find the initial amount, that means no time has passed yet, so t is equal to 0. Okay, let's look at the first problem. A can of soda is placed inside a cooler. As the soda cools, its temperature T of x in degrees Celsius is given by the following function, where x is the number of minutes. Okay, so that's going to be our changing variable right there. X is the number of minutes since the can was placed in the cooler. So here's the function, -6 plus 26e to the -0.04x. Find the initial temperature of the soda and the temperature after 18 minutes and round to the nearest degree. Okay, so as we said, the initial is t equals 0. So for the first one, I'll plug in a 0 there. So it'll be -6 plus 26e to the -0.04 times 0. Okay, so we could do this in the calculator. However, we know that 0 times 0, or 0 times this is 0, right? So that would turn into -6 plus 26e to the 0. We also know that anytime you raise anything except for 0, anything to the 0 power, you get 1. Okay, so this would turn into -6 plus 26. Okay, given that, we know we can add these together and we get 20 degrees. And we can confirm that in the calculator in a second. Let me go ahead and write down the second one. Oh, by the way, this is in degrees Celsius. Okay, so the second one says 18 minutes, right? So t is equal to 18, or x is equal to 18. So we plug in an 18 to the function, -6 plus 26e to the -0.04 times 18. Okay, so for that one, we would definitely need to go to the calculator to get an accurate answer. Okay, so here's the TI-84. Let's go to y equals. We'll type in the function -6 plus 26. Let's see, how do I get an e? I hit second ln. That'll pop up an e. And for the exponent, I need -0.04x. Okay, so there's a function. Now I can go to my table by hitting second graph, and there's some values. We can see that the first one's confirmed. If I plug it into 0, and for x I do get 20. Okay, we could scroll down to get the 18. Scroll down all the way down there, and the 18 is 6.6556. It says round to the nearest degree, so that's going to round up to 7 degrees. 7 degrees Celsius. Okay, you can also hit second window and go down here and tell it to ask on the independent. And now when you go to your table, it gives you an open table, and you can just type in the number you want. We wanted 0, which gives us 20, and we wanted 18, which gave us that answer. Okay, so let's look at the next one. The number of bacteria in a certain population increases according to the following function, where t is measured in hours. Here's the function. Notice the base of e there. Find the initial number of bacteria and the number of bacteria after 7 hours. Okay, so initial, remember initial means time is 0, no time has passed, so p of 0 was 2000 e to the 0.13 times 0. Okay, so just like on the last problem, when there's 0 in the exponent, this whole thing becomes 0. And then e to the 0 is 1. So you end up getting 2000 times 1, which is just 2000. Also, when you have a function that's set up like this is always going to be your initial amount, right? Okay, but you can always plug in the 0 to find out. Now let's plug in a 7. So 2000 e to the 0.13 times 7. Okay, so for that we need to go to our calculator. So let's clear out that first one. We'll put in 2000 e, that's second ln, 0.13 times 7. And then we can go to our table and we can tell it what value do we want. We want 0, and we want, hold up just a second. Let's see here. Oh, I shouldn't have put a 7 here, of course. That's a variable. There's my mistake. So here's the function without a 7 there. That's an x. And now we can go back to our table and plug in 0. We can also plug in a 7. There are our two values. So as we said, the first one is 2,000. The second one is 4,968.6. So we will round up to 4,969. That's how many bacteria there are.